What I want to do is really try and share some of the science so that we've seen a lot of stuff, we've done a lot of great things, but I think we also need to dig a little bit deeper into what the evidence is. I talk to a lot of global audiences, especially senior executives, on global risk. If you've got a chart like this, there's a concern and the board gets together and tries to figure it out. But actually what that is the Arctic summer sea ice. It used to be that people thought we'd lose the summer sea ice by the year 2100. Now it's very likely we'll lose it in the summer 2050, maybe 2030. Hard to say, but we are really in a situation with the Arctic summer sea ice that we've got a problem. That isn't happening on its own. It's really happening because of the big Earth system, which scientists called the Anthropocene. What the Anthropocene means is this is a period, an epoch, where humans are the dominant driving force on all ecosystems in the planet. So there's all sorts of stuff that's going on, and that is called the Anthropocene, and that's essentially where we are. But there's very good evidence from a variety of different ways in the geological record that looks like we are actually the driving force on the planet. So it's not just that the impact's really big, geologically we are the ones driving change on a variety of different records. What scientists did in 2009 was they tried to figure out what were the key ecosystem processes that kept the Earth in a condition where humans could thrive. So these are like the key performance indicators for the planet. And they figured out that there's 9 of them, and they summarized tens of thousands of scientific studies to do this. They then tried to measure what is a safe space from a global perspective, and then measure how far are we within that safe space. So if we look here, we can clearly see at the top climate change, and we're definitely in the orange. The reason why we're not quite in the red is, first of all, this is a 2015, but also the time frame. We're not, it's not disaster yet, although we're fast approaching tipping points. But what you will see is over here to the left that we've got biodiversity here, massive problems. We're well in the red in terms of genetic diversity. We've lost 1 million species, largely because of human activity, 1 out of 8 species in terms of extinction. That's a huge problem. We can also see land use change, also significant. We have enough fresh water globally, we just don't have it in the right places. So when we start to dive deeper down to a local or regional scale, that's when we have a big problem, and that's where we get a lot of conflict over water. Then when we have at the bottom here, another red, red, red. So these are biochemical flows. This is nitrogen and phosphorus. Nitrogen you take out of the atmosphere, phosphorus you dig it out of the ground. You mix them together as fertilizer, and that's how we make our food. Massive overshooting, not just in Lake Erie, right? Lake Erie at Toledo, that's the big algae blooms. This is the problem in terms of planetary level. When you overload it in terms of how we make our food, that means that the soil is not very healthy, not very resilient. So food security in the long term is a definite threat on this. Now, ocean acidification is not at a danger level yet, but it is directly related to CO2 emissions. So CO2 goes into the oceans, it changes the chemical composition of that, and can mean sort of death of life in the oceans as things start to break down. It's just a different chemical balance, and we don't have any more fish, etc., that can feed on that. We've got pockets of it in certain places around the world. We just don't have it everywhere in the ocean, thank God. But it is a huge problem. Now, atmospheric aerosol loading, that's like air pollution. That's stuff we put into the air. From a climate perspective, some of the air pollution is actually kind of good because it gets shiny and it bounces sunlight back out. But for human health perspectives and being in a big city where there's a lot of pollution, that's not healthy. But from a science perspective, we actually don't know what's a safe space for the planet. We know that certain cities are well beyond a safe space, lots of cities in Asia, London, Paris, New York, but what we don't know is how the planet actually needs that in terms of the guidelines. So that's a question mark. Ozone depletion, that's probably the one good news on the chart. The ozone hole, probably, I grew up as a kid, there's a hole in the ozone, and that's why everybody was starting to get skin cancer, and related to aerosols that we were using for things like refrigeration. The world got together, Montreal Protocol, and they largely solved it. So this is, we can see the ozone depletion, there's some changes that happen, but largely that's in a blue space. So that's a good news. And we can always keep that in mind, that when we see these big processes in the red or in the orange, we know that actually we do have the capability as humans of coming together and doing things. Now, novel entities, what is that? In 2009, we called that chemical pollution or release of harmful chemicals, but now we're knowing we're releasing all kinds of stuff, and they're not just chemicals. Some of those are nanoparticles, and then it gets, lots more coming in. We have no idea on a planetary level what is the safe space on many of these things, whether it's microplastics, you name it, all the chemicals, we don't know. So those are question marks. But what we can see is a lot of these actually interact together. So while we talk about climate, we have to make sure that the solutions to climate change don't affect things like biosphere integrity, so biodiversity, which is the whole issue with, say, biofuels. It could be on land production, so we can't convert all land into corn and use that for ethanol because we actually need more biodiversity. So these things work together, and they're essentially the dashboard to govern a sustainable planet. And that's what science does. So science starts to do these things. Now, we want to look at CO2 specifically. It is true that the planet has had a lot of different climates. Essentially, this is 100,000 years. So this is the period of time that humans have been on the planet, roughly. Now, the planet, as you'll see here, has actually had quite a different sets of climate, right? So that is true. And that's very natural. And then all of a sudden we see here, which is the last 10,000 years, a very stable planet. These are natural processes, so natural variability in climate does happen. And we can see for 10,000 years, though, we actually had a really stable climate. And during that 10,000 years, human population massively expanded, rise of the great civilizations. Now, I said that we're now entering the zone of the Anthropocene. The zone we're leaving is this one. That's called the Holocene Period. And that's where there's a stable period of climate where we've been able to do all the things that we've been able to do. Now, the question is, where exactly are we now? And it's looking like the data is showing us that we're moving. Now, this chart looks at temperature anomalies both globally, and we'll have the global stuff going up here, but then you'll see regionally temperature charts from the year 1900 onwards, and it's going to be sort of colored coming up, and you'll see variability through this. So we see a lot of different things. This is an interactive from Berkeley, and it's really useful because it shows, first of all, there's fluctuations, there's annual variability, and we can also see that there's such an increase over the last couple of decades in terms of heat. And we can also see that it's disproportionately spread around. Different times, it's different things. And we can see Europe is massively hotter, Asia as well, Africa as well, but Africa already started off with a lot of challenges. So what we can see is this is observational data. This is not a model, so this is not what we think might be happening. This is what is happening. It's just observation. And they've collected it methodically over time, and this is what it looks like. Now, from a good news perspective, we know in 2015 that the UN brought heads of state together and they came up with the historic Paris Agreement. It's an international agreement, and you have each national country has to make a commitment, but globally they agreed to keep the planet within 2 degrees Celsius as the ceiling. We can tell that if we want to stay within the 2-degree warmer world, Celsius, there's only a certain amount of CO2 and greenhouse gases that we can emit into the atmosphere. That's called the carbon budget. So if we want to keep within a 2-degree forever warmer world, humanity can only release 1 trillion tons of carbon. We've spent already half of that budget. So the other period of time through the Industrial Revolution, let's say, we already spent half the budget. And now for the rest of humanity, we only have that left. It's a forever budget, and we've already done half of it. Last year, the IPCC, which is the Intergovernmental Panel on Climate Change, really did a deep dive into, is 2 degrees Celsius actually the ceiling? The answer is no. The safe space is 1.5 degrees Celsius. Why? Because it matters for impacts. Ecosystems move, but what we can see, and we've got warm water corals, mangrove, low-latitude fisheries, the Arctic on the 4th there, terrestrial ecosystems, which means land-based ecosystems, coastal flooding, fluvial flooding, that means flooding inside off rivers, crop yields, tourism, and heat-related morbidity and mortality. We can see that 1.5 C matters for many of those impacts, and they tip quite quickly. But if we take a look here at the Arctic region, at the 1 degree, we're already starting to get deep orange, right? 1.5, we're in a dark red. That's super bad news. Now, why does that matter? Well, that matters because once the Arctic tips, it will amplify all of this massively. So it's not just like, oh, we lose the corals and that's sad. No, we lose the Arctic summer sea ice, or Greenland destabilizes so significantly, we cannot stop it and we have runaway climate change. So that's why we really need to focus on 1.5, and we need to deal with that now. There's a couple of processes within the Arctic that are important. This is summer sea ice. So this is over time. So the Arctic in the summer used to be all like that. So what we can see from this is a pretty steady downward trend. We do see variability. 2012 was an incredibly bad year. Why does the sea ice matter? It matters because it's white. It has an albedo effect so that when the sun comes in, it bounces it back up. It doesn't absorb it. And that's really good news, so it doesn't amplify the warming. When it's open, water, more and more and more water absorbs that heat, which traps it in the ocean, warms the ocean, adds in a different chemical composition to the ocean, and warms the whole planet, changes the way the ocean circulation works. So we want the white, and we're getting less and less and less of that. Try and remember New Year's Eve 2015. Now, at that time in the Arctic, temperature should be around -20 Celsius, -30 Celsius. Well, in Svalbard Island, which is in northern Norway, we were at +6.4 Celsius on New Year's Eve 2015. Most people did not pay attention to that. Why is that happening? Because the whole climate system is getting variable and going out of whack. So what we're starting to see is these massive spikes. Throughout the Arctic this summer, 20, 30 degrees in places. We had wildfires in the Arctic, much more than we would normally do. Greenland was also burning. The Arctic is in crisis. We've had a 50% reduction in the thickness of sea ice since the 1970s, 50% area loss in terms of the same period. 75% of ice volume is gone in the Arctic today since the 1970s. Multi-year ice is different. You can see it. It looks more blue. It's a different color when you're out in the sea and you're out in the ocean. Multi-year ice, there used to be lots of it. 95% of it's gone. If we take a look at Greenland Melt, this is a slide from this year, we can see that again, you've got variability. When you've got the summer temperatures, it does get warm. What we can see in terms of the melt this June, massively bigger than normal. Another alarm bell. The system is in crisis here, and we can see that's why the Arctic is important. Also because not enough people outside the Arctic or outside of science are really paying attention to this. Greenland is a glacier, both loses ice every summer and gains snow cover every summer. That's how it works. And usually until the year 2000, they evened out so that the mass of white was the same. As of 2000, we know that we are losing more ice than we are gaining in terms of snow. And how much are we losing? 350 gigatons of ice. 350 gigatons is equivalent to all the ice in the Swiss Alps. This picture was taken by one of our research colleagues from Denmark. This is where they're supposed to be going on dog sled, and they simply cannot get there in the same way. If we look at who is responsible, I think that's important. There's good science that shows that Arctic summer sea ice directly is related to how much we are emitting on CO2 greenhouse gases. We can see for the US here, 5.3 gigatons of CO2. That means that they melted 90 times the size of Washington, D.C. in terms of summer sea ice. If we look at the EU, another huge emitter, 100 times the size of Paris. China, 10 times the size of Hong Kong, approximately the size of Belgium. In India, we're looking at about 5 times the size of Delhi. We are responsible for this situation in the Arctic. So why should we care what happens? You'll hear that actually an ice-free Arctic is good for the economy. There's benefits from Arctic shipping. We've got new sea routes happening here. It's cheaper. Ships are using very, very dirty fuel with a lot of exhaust. That's the black stuff, the bad stuff, and a lot of other particles come out of that. And we estimated that those hidden costs, $10 trillion US in terms of incremental climate impacts. And again, it just keeps adding in. We've also looked at what happens if the permafrost in Siberia, Canada, US, Alaska, etc. melts. What's the cost of that from a climate perspective when that releases the methane into the air? That's a $40 trillion US cost. We estimated what is the cost of losing that permafrost and losing Arctic summer sea ice. That's 70 trillion US dollars. So what we're talking about here is that losing the Arctic is not just bad news for the polar bear. It's actually, there's a strong economic argument that there will be costs from this. Also, though, it's disproportionately distributed around the world. Asia, China, low-lying states, parts of Africa, other parts, they will disproportionately pick up the costs of this as well. What we try to do is say, actually, if we look at the cost of mitigation, it makes more sense to try and stay between the 2 degrees Celsius and the 1.5. It's cheaper than getting the 70 trillion US dollars. If we take a look at the insured losses, massive. Last year, extreme weather, 300 billion US dollars. That's the cost of the losses. It's expensive. Now, if the Arctic summer sea ice melts, sea rise doesn't happen. It's like an ice cube in water, right? Because the ice is already in the water, so if it just melts, but if you add in an ice cube, the water goes up. And the ice cube we're adding in is Greenland. And we're getting the rise on this. And there's coastal populations and assets exposed that are massively. So the top ones would be Kolkata, Mumbai, Dhaka, Guangzhou, Ho Chi Minh City, Shanghai, Bangkok, Yangon, Miami, Haiphong, Alexandria, and Egypt, Xinjiang, Bangladesh, Ningbo, and so on, and we start to see things. But when we look at the actual exposed assets, Miami, top of the list, most exposed assets in terms of sea level rise. We also can see, though, because the Arctic feeds into the whole climate system, and this has not been estimated so much in terms of the costs, but we do know that the hottest temperature trends in large cities has also massively gone up. The chart on the left is if we look at 1966 to 2015. The chart on the right is just actually taking a shorter period of time, 85 to 2015. And we can see in terms of Celsius, Paris has already gone up almost 1 degree Celsius since the 60s. Houston has gone up 1 degree since 1985. These are big shifts in terms of infrastructure, in terms of quality of life. So remember, those cities are already living at a 1 degree warmer world. And there's big changes that come with that. Economies most at risk from flooding, so even with little bits of sea level rise and all different precipitation patterns, so more rainfall, we can see that the flood-related damage all over the place. US number 1, number 2, China. So in terms of the flooding costs as well, really, really important. Now, flooding isn't only because of the Arctic, but the Arctic amplifies that and increases it. We also know that there's global agricultural impacts. The Arctic affects the way rainfall, snowfall happens around the world, also brings in extreme weather, and as weather changes, it also brings up different disease. And we don't actually know yet what the impact will be on key commodity crops like maize, rice, wheat, and potatoes. Global CO2 has risen again 2.3%, which is really bad news. We are not leveling off. We are continuing to rise. Why is that happening? Well, that's happening because China and India still heavily rely on coal, and because the rest of us, US, Europe, and the rest, have not decarbonized faster. We've got the Paris Agreement. What we don't have is deep action. Despite all the good stuff that's happening, despite the low economy that's happening, the way we're driving our cars perhaps, or heating our homes, globally up 2.3%. It's not only climate change. Biodiversity, which I showed in the very opening with the Planetary Boundaries framework, is under absolutely massive pressure. Millions of species at risk, 1 out of 8 facing extinction, most of this related to human activity. Biodiversity is useful for many things, if you need those pollinators to do your crops, but it also is a climate change buffer. The more stuff you've got out there, it will buffer it. So if you don't just lose one species, and it was the keystone species that did all this other stuff for us, you have more things. We're getting less and less and less. And it's at such a level that the Club of Rome, global scientists and former heads of state in New York at the UN meetings in 2019 officially launched a planetary emergency declaration. It's a systemic risk, and it means it's an emergency. What makes an emergency different from a systemic perspective? It's complicated. There's things at different scales, time and space. Hard to know what our piece of the puzzle is, how we do this. There's no global governance around the planet. There's nobody in charge. There's only us in charge of pieces. And what we're recommending is 10 global commitments and 10 calls to action within the next year to get us to a significantly better place by 2030. So the game is on, and we've got to move forward rapidly in the next decade. If we take a look at limiting global warming to 1.5 C, we have to have deep emissions cuts. And by 2050, net zero emissions. So a good question is to really consider what is net zero in terms of emissions. And it really is net zero. What that means is by 2050, we are not putting any more greenhouse gases into the environment. Now, what does that mean? How are we going to do that? Well, we're going to have different forms of energy sources. We're going to have circular economy things so that we use the stuff we already have in a circular way. It will mean that we have to have much more forests and use smart agriculture so that we build those carbon sinks back in. We restore the land so it can capture that carbon. That's one way of capturing it out of the atmosphere. And also we'll probably have to have some carbon capture and storage in terms of technologically putting that carbon somewhere else. We really have to massively transition the economy and how we live our lives, travel, eat our food, make our stuff, so that we get to net zero by 2050. And the next decade, between 2020 and 2030, is really the race. This will be when we figure out if we're going to be able to do this in an orderly way. If we don't, it doesn't mean the planet finishes. The planet doesn't finish, right? I showed you that the planet continues. But it does mean that we will be setting off, likely, runaway climate change. So we are walking into catastrophe, and this is the guidepost. Is there any good news? Well, there is good news, actually. We can see that renewables overall are picking up in terms of the global energy supply, and importantly, solar energy has massively become affordable. 80% drop in costs in the last decade. Huge transformation. So as much as we might say, we can't get to 2030 with where we need to go, yeah, actually we can. We've seen what we've done in certain things, in innovations, and quite large deployment in ways to get there. Is it enough? No. Solar alone is not. And then what we've got in terms of the commitments, we've got all kinds of things that has to happen soon, and certainly within the next decade, in order to get us to net zero and deal with the biodiversity loss that we have. We've got to understand that the Earth is a critical ecosystem with a global commons. No one's in charge, so we really have to commit to that politically. By 2020, we have to have a universal global moratorium on deforestation. No more deforestation. No more of that kind of Amazonian fires happening. By 2020, we have to have an immediate moratorium on any Arctic oil and gas development. We have to enhance, of course, public and private financial flows. We need the money to come in to just sort of turbocharge the economy. We have to look at the decline in ocean ecosystem and habitats, really deal with a strong ocean treaty. We have to have a public-private planetary emergency fund so that when the crises start to hit, the money is there to address that. We've got to make sure that all sovereign wealth funds commit to defunding deforestation. No more funding of deforestation. It's just not going to happen. We have to have by 2025, all companies, whether they're publicly or privately owned, family businesses, have to commit to science-based targets. Companies need to know that they have to operate their economics within a planetary set of guidelines. We have to halt all conversion of wetlands, grasslands, and savanna. And we've got to triple investments into the restoration. And finally, we've just really got to have a whole whack of new policy instruments and financial instruments, whether those are going beyond green bonds to fund this. Because without the money, the game plan is just not going to happen. So the bottom line is the crisis is there. It's happening now. The Arctic is a clear indication of what is happening. We have to act collectively, and we have about 10 years to get that plan, not just developed, implemented. But the good news is that it's still doable. We wait to 2030, I don't know. I just don't know.